Hi, welcome everyone. Start all over again. This session is for data scientists and machine learning engineers that want to deploy generative AI use cases to production quickly and reliably. Let's start by looking at three key trends that are emerging with generative AI. Customers' spend on generative AI grew by 2.5x in less than a year, going from $7 million annually to $18 million. Customers are increasingly relying on multiple model providers for building generative AI applications. And lastly, with the advent of high-quality open-source foundation models, customers are now relying on pre-trained foundation models and customizing their behavior over building their own foundation models for these generative AI use cases. This is an important takeaway as we dive deeper into our presentation in the next 60 minutes. Hi, I'm Amit Modi, Senior Manager of Product Management for SageMaker AIOps, Governance and Responsible AI. And I have with me Shelby, who's the GenAI AML Specialist, Solution Architect and Data Science Leader, and Diane, who's Director of Engineering for Rocket Mortgage and one of our customers. We'll start with a 2-minute quick overview of what is MLOps, what SageMaker MLOps capabilities are available to you today, and then we'll build on top of it to define what is FMOps, GenAIOps, what are the key challenges in implementing FMOps and GenAIOps, and how can you overcome those challenges to deploy your applications. The foundation of operationalizing any AI/ML workloads is governance that spans across AWS services, data, model, as well as applications, such as managing the model throughout the entire life cycle from development, deployment, monitoring, and risk auditing. Similarly, for data, that implies controlling and managing access to data so that you can control the quality of training data for accuracy, output of the results, as well as privacy. MLOps builds on top of governance and spans across and brings the practices across people, process, and technology to help you build scalable, repeatable, and reliable workloads. And you will see that's the common theme across GenAIOps and FMOps as well. Let's take a quick look at what are the MLOps capabilities that are available to you today in SageMaker. SageMaker already provides capabilities for reliable and automated experiment tracking, managing models at scale as you go from your first model to thousands of models, capabilities to build automated build pipelines for your models for training and as well as fine-tuning, and capabilities to deploy and monitor the performance of your models. And it comes with some pre-configured capabilities that help you standardize AI/ML workflows and incorporate CI/CD. Lastly, it also offers capabilities so that you can document your use cases and risk for governance, risk, and compliance. Now let's take a look at what is FMOps. FMOps builds on top of MLOps and brings in unique aspects that are relevant for only FMOps, such as selecting and evaluating foundation models, using prompts to modify and manage the behavior of the model, or implementing safeguards as your users interact with the foundation models to filter out sensitive data, harmful content, or even prompt injections. GenAIOps builds on top of FMOps and brings in unique aspects that are required for building entire end-to-end GenAI solutions. With the rise of GenAI, we have seen new paradigms evolve, such as capabilities to build agents, augmenting foundation model with secondary sources of information, or specialized capabilities to trace your GenAI applications and observe their behavior in production. So to quickly recap, there are certain capabilities that are common across MLOps, FMOps, and GenAIOps, like experiment tracking, integrating your model with the application, monitoring the behavior of the model after it's deployed to production, and incorporating feedback loop based on the human response. And there are certain aspects that are only common between MLOps and FMOps because they're related to training or fine-tuning the models, or deploying the models. And lastly, there are certain unique aspects that are only common to FMOps and GenAIOps, like prompt management, which are only relevant in the context of foundation models, where you want to modify the behavior of the model. So one thing to note is that even though conceptually all these concepts are same, the implementation details may vary as you go between MLOps, FMOps, and GenAIOps. And we'll dive into those details in the next section. Based on the customer conversations over last year, we have identified 8 common themes that come up again and again in our conversations. We have identified those as challenges, and in this section, we'll talk about what are those challenges, what are the actionable recommendations to overcome those challenges, and then Shelby will walk you through a demo that brings some of these capabilities that we'll walk you through to life. So let's start with the first thing. To produce high-quality results, you need to often fine-tune foundation models. One of the big challenges with fine-tuning a foundation model is having high-quality training data. For high-quality training data, you have a dependency on a human annotator, which often becomes challenging as you are trying to pre-train the model. Let's take an example to see why this is so challenging. Let's say we are trying to fine-tune a model for a specific task or a domain using supervised fine-tuning. In this case, you want to provide model with the prompts and desired output, and so that you can provide that back to the model and you train the behavior of the model. Or let's say you are using another human preference to guide the model behavior. In this case, you would ask humans to rate the responses and then use that feedback to train a reward model and then feed that reward model back to the fine-tuned, to the foundation model for fine-tuning. In both cases, you can see why there's a dependency on the human annotators for fine-tuning the foundation model. You need a tool, in this case, that can provide you an easy interface to provide feedback, one, and two, that can be integrated into your model development pipelines so that you can incorporate this human feedback as part of automated pipelines. SageMaker Ground Truth offers both of these capabilities. You can already see the visual aspects of the easy interface here, and then it also has certain capabilities that allow you to build the model development pipelines. Next is the experiment and the model management. As you build out FMOps and GenAIOps applications, you need to track the experiments and the associated metadata. For example, what models did you use? What evaluation metrics did you use to accomplish a particular step so that you can go back and revisit them for repeatability or traceability. Let's take a look at a fine-tuning job here. For a fine-tuning job, you can see there are a lot of model input and artifacts that are required to be tracked as part of the experiments. Manually tracking these artifacts and model inputs is tedious and error-prone. So you need automated experiment tracking to make sure your experiment tracking is reliable. Customers tell us that they love open source MLflow for tracking experiments. However, they don't like that they need to take on the burden of managing the infrastructure for hosting MLflow. And MLflow is a rapidly moving product. So the customers have the onus to upgrade a version every time a new version is released, or they want to adapt to the latest version of MLflow. And lastly, they have to go and integrate IAM permissions or various other SageMaker capabilities so that they can, one, make sure only right data scientists can access the tracking server, and two, they can log experimentation metrics from their preferred development environment. To address some of these challenges, we launched Managed MLflow on SageMaker in June, which solves some of these problems. Now, with a couple of button clicks, you can launch an MLflow tracking server, which comes pre-configured with SageMaker capabilities. So you can log experiments from notebooks in Studio, or from training jobs, or hyperpod clusters, or from even your local IDs. And you can use IAM permissions to configure the access to right people to this tracking server. Once you have evaluated the models, you can choose the right candidate model that you want to take from your development environment to staging environment. You can register that model into MLflow model registry, which automatically gets synced into SageMaker model registry. This makes it easy to deploy the model on SageMaker inference endpoints. And if you are using some other infrastructure for deploying your models like EC2, EKS, or Bedrock, you can accomplish that directly from MLflow model registry. This helps you build an automated and a reliable experiment tracking system for your FMOps and GenAIOps. Next, let's take a look at the prompt management. Prompt management is fairly new concept, and with this rise of prompt management, we are seeing new personas emerge who want to interact with foundation model for modifying its behavior. And these new personas have different preferences in terms of tools. Some prefer using playground-like tools where they can interact with the pre-hosted foundation model through APIs, or some prefer classic model hubs like Jumpstart, where they can host the model endpoint and interact with the model through the notebook. Irrespective of the tool that is used, with prompt management, you want to make sure you are following two best practices. One, for prompt patterns, you are saving the prompts as prompt templates and prompt data. And second, you can combine the prompts with the evaluation results so that you can go back and track these prompts and the results. The overall benefit of following these best practices are three reasons. One, it reduces the cost across different experiments because you can borrow the patterns or the data for prompt management for other models. Second, by augmenting prompt templates and data with versions, now you can have repeatability and traceability into your experiments. And lastly, it makes it easier to collaborate between different teams so that other teams can follow the best patterns that you have identified for prompting with the foundation model. Next, let's dive into building repeatable workloads. So far, we have talked about how you can fine-tune the model, how you can extract the experiments, and manage the behavior through prompts. Now, how do you put together all these pieces so that you have a fine-tuning pipeline that can also incorporate human feedback, or in some cases, help you build RAG applications? SageMaker Pipelines is a tool that helps you build out these model development end-to-end pipelines. You can access SageMaker Pipelines through a drag-and-drop interface or a SDK. If you already have code in your notebooks that you want to convert into a pipeline, you can simply use a decorator and wrap up the code with @step, and that converts it into a pipeline step, removing the effort required for you to do a heavy lift. You can, if the pipeline steps have previously been successfully executed, pipelines skip over those steps, which reduces redundancy and helps you run the pipelines faster. Pipelines come pre-integrated with most common SageMaker capabilities that you need in your model development pipeline. For example, training, processing, registering a model. So you can simply invoke these functions and without writing any additional logic. If you need to integrate beyond these capabilities, we have callback functions available that make it easily extensible. And lastly, pipelines are integrated with EventBridge. So you can schedule the runs at a specific time or at a specific event. For example, when you want to trigger fine-tuning job, when new data arrives in S3, you can trigger that using EventBridge. And most importantly, pipelines are serverless. So you can configure pipelines without the burden of managing the infrastructure that's required to orchestrate your end-to-end workflows. Next, let's talk about evaluation and monitoring. With GenAI and FMOps, there's a much broader need for evaluation metrics. So we should look at what are the key considerations we need to make as we think about GenAI applications. So first, you definitely need a model evaluation that can help you measure the performance of the model as well as the risks associated with it. You also need data evaluation across the life cycle. Before training, you need data evaluation metrics to make sure your data is relevant and high quality for training. And in certain cases where you are augmenting foundation model with secondary sources of information, you want to make sure you can measure relevance of the data. You also want to incorporate user feedback based on the model response to make sure your model is performing as expected. And lastly, you also want to think about how you want to measure agents, which can be a lot more complex as you think about the entire GenAI applications and the workflows. And last but not the least, you need system metrics to make sure wherever the model is deployed is utilizing the resources so that you have a performant and a cost-effective model. So in the next set of slides, let's talk about some of these challenges a little bit more deeply and which capabilities you can use to overcome those challenges. With SageMaker MLflow as well as Clarify, you can kick off model evaluation. SageMaker with MLflow offers evaluations that you can be accessed through MLflow libraries, and you can use them to evaluate traditional models or generative AI models. You can also use native capabilities like SageMaker Clarify to evaluate models with automated or human feedback. The most important thing to keep in mind is that irrespective of the tool that you use, you want to make sure your evaluation metrics can be integrated back into the pipeline so that you can build scalable, repeatable, and reliable workloads. Now, next, let's talk about agents, because this is a little bit more different from traditional ML. Building an agent is an iterative process that requires a lot of interaction with the agent, and you often have to provide model output. However, this approach is not really scalable if you're trying to build a high-quality agent. Also, how do you go about operationalizing an agent with an automated pipeline if it requires constant manual feedback? To address this, you can use open source agent evaluator, which comes pre-integrated with Q, Bedrock, and SageMaker services. Internally, this evaluator has an LLM called Evaluator LLM that interacts with your agent or the target agent, and it evaluates the responses of your agent and then provides metrics back that can be integrated into your pipeline to make the right decisions. Now we have talked about evaluations, but how do we go about tracking the behavior of the model once it's deployed? For ongoing observability and monitoring, you can use AWS services to log, collect, measure, and set alerts on key metrics. You can also integrate these AWS services with open source tools like OpenTelemetry or OpenTelemetry. And by incorporating all these tools, you can make sure you have the right infrastructure. Next, let's talk about now you have a model that's been evaluated and it's ready to go from development environment to testing environment or production environment for deployment. One of the big challenges in this is risk compliance and governance. You want to make sure you have one place to track all your models that are going to be deployed to production, and you have the right artifacts associated with the model. SageMaker Model Registry solves some of these challenges. It provides you a single source of truth for all your models where you can log all your candidate models before they are deployed to production. It automatically captures the information from the training jobs, evaluation results, so that you can later use that information for traceability or for compliance and audit. And lastly, you can share the models across environments to make sure you are deploying the exact same model that was tested into the production environment. SageMaker Model Registry also helps enterprise customers who have multiple AWS accounts, often 10 to hundreds or even thousands, to build out a centralized model registry across all your accounts so that you can not only manage and monitor the models in your AWS account, but across all AWS accounts. Next, let's talk about implementing safeguards. One of the key aspects that we talked about that was unique to FMOps and GenAIOps was users interacting with foundation models through prompts. When users are interacting with the foundation model, you want to make sure you can manage that interaction. For prompt injection attacks when a user is sending prompts to the model, and for responses from the model to avoid hallucinations, hateful content, or any other harmful behavior. Across the life cycle, you have different tools that you can use to safeguard this. Early in the process, you can restrict access to a particular model depending on your licensing policies as well as your corporate policies. Or later in the stage, once you have deployed the model, you have two options. If you're using SageMaker inference endpoints for deploying your model, you can use Bedrock guardrails for common scenarios like filtering out content, for denying certain topics, and to even restrict PII or personal information. You can also build your own safeguards with LlamaGuard and host them on the SageMaker inference endpoint and make sure you can customize the behavior as you need. Lastly, as we think about deploying models in production, a key aspect to all of this is making sure your model is performant but also cost effective, because generative AI applications can be expensive. AWS provides different capabilities at each layer to make sure you have the most cost performant model. For example, AWS provides optimized compute like Trainium for training your model, or optimized compute like Inferentia for hosting the inference. For this particular section, I'm going to cover one such capability that is available at the service layer, and then we'll give you resources at the end that you can read to explore other capabilities as well. One of the most commonly used techniques for fine-tuning the models is that customers freeze the base model and modify or certain adaptive layers to fine-tune the foundation model. This approach is very cost-effective. This means you can take the foundation model and have adapters for HR department, for legal department, and for marketing department. And when you deploy the inference endpoint, you can pull the right adapter and give the response back. So you can have 3 adapters with the inference endpoint in our use case. However, this becomes increasingly complex as you start to scale adapters. SageMaker inference endpoints natively support multi-adapter inference endpoints. So all you need to do is register your adapters along with the inference endpoints, and SageMaker inference endpoints takes care of loading the right adapter to respond to the query and serve the query back within few milliseconds. Now I'm going to hand over this presentation to Shelby, who's going to do a quick demo to bring some of these capabilities to life. Thank you.
All right, thank you, Amit. And thank you to everyone for joining early on a Monday morning. I know it's rough, so appreciate everyone being here. Let me swap over to the demo real quick. Touching on 3 of the aspects that Amit touched on earlier. So specifically on reliable experiment tracking, creating reliable iterative workflows, in this case, specifically iterative workflows for fine-tuning, as well as we'll talk about an example implementation of implementing safeguards as well. So to begin with, we're going to start with a simple use case. So let's say we're going to build a QA chatbot, and we're going to experiment with a base model through simple prompting, and then we're also going to look at, can we further fine-tune that to increase the performance or optimize the performance of our QA chatbot. So to do that, what we're going to do is we're going to use an open data set. So it's just an open data set, sample data set that is specifically annotated by humans. So high quality human annotations, which Amit talked about as well. And then we're going to combine that with a base model. In this case, we're going to go with Llama 3. And first, we're going to do some prompt engineering to see what kind of performance we can get out of just that base model. And then we're going to look at how we can fine-tune and compare the results of that model. So for this, we're going to do experimentation out of Studio, specifically in a notebook environment. But like Amit mentioned, you can use MLflow through local IDs, through any other environment, just through APIs. But in this case, we're going to use it through our Jupyter Notebook. And we're going to evaluate using an evaluation data set. So this evaluation data set is one that we're going to use for both our prompting experiments, but also for our fine-tuning experiments. So we're going to skip some of the setup. You've all probably seen this setup before. But what we're going to do is select a candidate model. So again, we're going to use a Llama model. Going to load that into our notebook for experimentation. And you can adjust the size of the compute and the storage for those that are unfamiliar with notebooks inside Jupyter Lab. So you can adjust the compute, the storage of the underlying notebook itself. This is one example for smaller scale experimentation. Ephemeral compute is typically something that we use for larger scale experimentation. But in this case, we're just going to use the underlying compute of the Jupyter Lab environment. And one prerequisite to this is setting up the MLflow tracking server. So like Amit mentioned, it is just a couple clicks within the Studio console itself. So you basically click on MLflow, you give a name to your tracking server, and then that tracking server spins up in roughly 20 minutes or so. And then you can make that available to all your data scientists or even ML engineers who are doing some experimentation. So for this, we had to pre-do that, obviously, because we don't have 20 minutes to wait for our MLflow tracking server to come up. But after it does come up, you'll see it has an ARN, like every AWS resource, right? So it's a unique identifier for that tracking server. And then we'll give our experiment a name. In this case, we're going with QA chatbot model evaluation. And then we'll set up the experiment itself. So in this case, we're just setting up an experiment. So within MLflow, there's an idea of an experiment and then runs within that. So the runs are going to be the individual runs of an experiment. So in this case, we're going to have a run for prompt management alone, and then we'll have a couple of runs for fine-tuning and compare the evaluation metrics based on those different ways of customizing a model. So we're basically starting an experiment. We're starting a run of that experiment. And in this case, now we'll run our evaluations, again, using that evaluation data set that we curated before, same one we're going to use for fine-tuning. And to start our experiment, you can see, and we're showing kind of the codified version inside here, but to start our experiment, we're pointing to our data set on input. So it's an evaluation data set. We're also, in this case, we're going to use MLflow's native built-in evaluation capabilities. So MLflow does have an evaluation library that you can use for different types of models, different types of tasks. And specifically, since this is a QA chatbot, we're going to go ahead and use the built-in model type of question answering, which will emit metrics that are very specific to Q&A tasks, right? You can do like summarization as well within there. In this case, since it's a QA chatbot, we're going to have it emit some of the metrics and do some evaluation of the metrics that are specific for QA. So once we've set that up, basically we will then run the evaluation function. So it's going to run the evaluation using that MLflow library as well as the tracking server ARN that we give it on input. And then, it's, as you can see here, it's kind of just printing out the first or the top 4 or 5 question answer pairs that are on the evaluation data set on input. And then it's running the evaluation. And you'll see once that's done, again, we pre-run this stuff because it takes a minute to run, of course. But you'll see at the end, it emits metrics that are specific to question answering, right? So toxicity, there's also, toxicity exact match, which is basically if on input, that evaluation data set, the question answer pair, was there any exact matches from that based on the LLM model response? And then toxicity measures the level of unsafe content. Now, these are just a few metrics, right? Typically, in a more holistic kind of evaluation framework, you're going to evaluate across multiple dimensions as well. Some of these metrics, probably additional metrics as well. Like, so if summarization, you can do rouge or blue scores. But also, in addition to that, evaluating for other aspects, so things like cost, latency, performance in terms of different aspects is pretty common. But for simplicity in this particular demo, we're going to go ahead and just use these out-of-the-box metrics. So this is our results for prompting alone, right? So say we want to go ahead and further optimize that by doing some fine-tuning and see if we can get some better performance with fine-tuning. So in this case, what we're going to do is set up a fine-tuning pipeline. So you don't always set up a pipeline necessarily for fine-tuning, but one of the benefits of setting up a pipeline when you do want to do some experimentation at scale across multiple iterations is being able to set this pipeline up, pass in runtime parameters that are different parameters that you might use to fine-tune. So things like, if you're using LoRa in this example, we're using LoRa, a parameter-efficient technique. We're passing in things like rank. So being able to kind of play with some of those hyperparameters in a more scalable way by just passing in runtime parameters. And to do this, we are going to use SageMaker pipelines. which Amit already covered. And it's just going to be a very simple pipeline with a few steps. So the input data set, again, it's a open data set with human annotations. So very high quality human annotation, question-answer pairs. Do some data preparation. Really here, we're just kind of filtering on the category of that data set because the particular data set that we use does have like open Q&A, has different tasks that it is useful for as well. Then we'll actually do our fine tuning. We're going to use SageMaker training jobs throughout the pipeline, which is essentially ephemeral compute, right? Very powerful ephemeral compute that spins up for the duration of a particular step run and automatically spins back down when that step is complete. And then we'll do our model evaluation step. And again, here for parity, we're going to use the same MLflow evaluation library as well. And then we'll log all of those experiments to the MLflow tracking server like we did before with our prompting example. One thing I do want to show you is, in this particular example, we're going to show the code because it's 300 level, and typically people really want to see the code behind it. There are drag and drop capabilities with pipelines that I just wanted to highlight. So you could create this exact same workflow inside the visual editor, where it's basically drag and drop. So you can basically bring in a data step, and then you can see inside here, you just kind of upload your data sets that you're going to use, a bunch of different input parameters. You can then have a fine-tuning step. So you just bring your fine-tuning step over. You can select a model from Jumpstart automatically to go ahead and do your fine-tuning with. And then just different parameters with that. So it makes it very easy to create these workflows. You can do it in an evaluation step, essentially with kind of custom code within there. And then basically you tag these together or stream these together for a pipeline. So I just wanted to show that. Typically, people want to see code in 300 level sessions, though. So we're going to go ahead and go back to our code and create this pipeline through code, specifically using remote functions. So we're going to skip some of this setup. There is some training configuration. So you'll see here, we're specifying the model ID we want to use. In this case, again, it's the Llama 3. We're specifying some things like around the instance sizes that we want to use for our fine-tuning. In this case, we're doing G5 12x large. Similar with instance types for like data processing. You could use different instance types for each step inside your pipeline, which is really powerful because you don't want to over-provision compute for any particular step inside your pipeline. Being able to kind of single that out per step is very important. So we're going to pass in some of those training configs. Again, here you'll see our tracking server ARN, which is the unique identifier for our tracking server, and then our experiment name. So we're going to go ahead and log this to the same experiment that we did for our prompting-only workflow. And this is just our data set. Again, we're using an open data set, a human annotated one. And here's where I was talking about some of those runtime parameters that you can pass in. So in this case, we are doing parameter-efficient fine-tuning, specifically LoRa. So what's nice about this is you can pass these in at runtime, right, and experiment across a bunch of different settings for things like rank or alpha or dropout. So the ability to pass these in at runtime is pretty powerful without having to change anything else. We're just going to give our pipeline a name. And then this is where we basically configure each of the steps. And all these steps are doing is basically taking in remote functions. So whatever script or Python code you're already creating to do this stuff, you're basically wrapping it around a step in a remote function so that it can be encapsulated within a pipeline. So you'll see here in the first step, we're basically just processing that open data set, kind of filtering out the ones that are optimized for QA. And we're doing that by calling preprocess, which if we look inside here, inside steps, you'll see preprocess is essentially our code to preprocess the data. Same with the fine-tuning step. We're pointing to our fine-tuning code, which is, again, inside here. In this case, we do have a training script that goes along with it because there's kind of more to it than just the step itself. But it's just pointing to fine-tuning code that we have within our libraries and running that. And then we have our evaluation step. Again, we're going to use MLflow's evaluation. If we look at that, inside each of our code, one of the things I should have pointed out is we do have, inside every piece of code, there is a MLflow. So we're basically tracking or logging our results to MLflow across the workflow. So not only for our data preparation, so that we're capturing all the metadata about that data for lineage, we're also capturing all the data, our metadata for training. We're also capturing all of our metadata for model evaluation. And then we'll just create the pipeline right here by specifying all the steps, and then we'll upsert. Upsert is basically just creating the pipeline itself. So creating and instantiating the pipeline. Again, all these steps are pre-run because sometimes they take some time in a live demo environment. We don't have that much time. But then we'll ultimately start it. So in this case, we're going to start it, one, with the default parameters that I showed you before for rank, alpha, and dropout. And then we run a second execution where we're modifying those parameters so that we can then compare performance across, like, how did those hyperparameters impact the metrics that we're actually looking at. And in this case, like I mentioned, we are only looking particularly at the built-in metrics from MLflow Evaluate for question answer. So, toxicity and exact match. So we're running 2 executions of the pipeline. So once all of that runs, each pipeline takes a little bit of time to run through. I think it's roughly 40 minutes or so in this case. But yeah, once we go through all of those, you'll see this is our pipeline. We can visualize it within Studio itself. So each execution runs. You can see these are the steps that we just created via code to pre-process the data, fine-tune the model, and then ultimately evaluate the model. Now, after all this runs, what we can do is go inside MLflow, which is what, again, that we're using for that reliable, kind of consistent experiment tracking and experiment management. And we can look at and compare across our runs. So if we look, this is the experiment that we had, the QA chatbot model evaluation. And you'll see our prompting only experiment is in here, as well as our 2 fine-tuning experiments. Let me try to bring that up a little more. There, is that better? All right, sorry. So our 2 fine-tuning experiments. And you'll see, because everything is encapsulated within the pipeline, you'll see our data sets information is captured within here. Also, if we go over to the side, you'll see our parameters that we're using to do fine-tuning. So that lower rank, the alpha and dropout is captured automatically. Same with the evaluation metrics, as well as the training metrics, right? So in terms of the evaluation metrics, we had toxicity and exact match, but also the training metrics. So there's additional training metrics, things like grade level, which is an indicator of the approximate US grade level that response is giving. And ideally, you want it to be not too complex, right? So it's just a measure of how complex that response is. So this would be roughly a 7th grade level in that response. So you can kind of easily go through, compare metrics. The other nice parts are, and one of the things that a lot of data scientists, ML engineers really love is kind of the visualizations as well. So not only are those metrics captured consistently, but you can also visualize those metrics across different runs. So these are our 2 fine-tuned examples, right? So they're the only ones that are going to have training metrics, of course. The prompting example is not, because we're using an out-of-the-box model. But you can go in and just really kind of easily visually compare across models what the different results were. And say we want to go ahead and deploy one of these models for further either deployment to production or potentially for integrating into things like additional safeguards or agents or a broader application. At that point, what you can do essentially is kind of go into one of these model experiments. And again, you'll see all these metrics are captured automatically. As you can imagine, this is extremely prone to human error if you try to do this or manually. So if we feel like this is a model that we want to then deploy either for further experimentation or for promotion to a production environment, we can register the model. And basically at that point, MLflow does have a model registry associated with it. In the case of MLflow and SageMaker model registry, by default, when you register a model to SageMaker's MLflow, it's going to automatically sync up to SageMaker's model registry. Because there are some capabilities native to SageMaker's model registry, especially when it moves on to deployment, that sync automatically happens. You can disable it if you want to. So that being said, after we have fine-tuned, let's say we want to then kind of deploy it, but then do more experimentation, like implementing safeguards or agents and that sort of thing. So in this case, I'm just going to show safeguards as an example. So implementing safeguards, there's different ways to do it, right? You can import SageMaker models, certain models into Bedrock and utilize guardrails out of the box with Bedrock, which I would highly recommend. It's kind of the easy button to do. But there are cases where maybe you want to, or different models that you're using, or even maybe in the case where you want to fine-tune a LlamaGuard model. So LlamaGuard is equivalently a safeguard, right? So it does input-output filtering for your generative AI models. So you may want to like fine-tune LlamaGuard or use LlamaGuard out of the box. But the way LlamaGuard works is you have a model, essentially, right? So a model that's deployed. A LlamaGuard model sits in front of that model and then does input-output filtering. So detect unsafe content and essentially block it out. If you don't want it to come through to the LLM model, return a default response back to the application. So to do that, and you'll see LlamaGuard, it has built-in detections, right? But you can fine-tune LlamaGuard too, as well, for your own unsafe content or own kind of customization that you want to use for detecting and blocking unsafe content. But you'll see here, basically, once that model's deployed, it'll hit the LlamaGuard model first. It'll detect if it's safe or unsafe. If it's safe, it's going to go ahead and move it back to the LLM, the fine-tuned Llama model that we just fine-tuned. If it is unsafe, it's going to just send a block message back to the application or user. So to do that, first we have to deploy the fine-tuned model that like best meets the performance requirements that you found in experimentation. So in this case, we're just deploying one of those fine-tuned models using kind of the Hugging Face built-in container for inference. So we are deploying it to a SageMaker endpoint specifically. And then we're going to implement or invoke the endpoint without safeguards. So this is just hitting that model directly through the SageMaker endpoint. And you'll see inside here, we ask, well, what's the best way to plan a bank heist? Our model goes ahead and tries to answer that, which is maybe behavior you want, maybe not. So what we're going to do is try to put LlamaGuard in place in front of that to be able to detect if someone's asking for criminal advice or things like that. So now we're going to go ahead and deploy LlamaGuard. In this case, we're just deploying the out-of-the-box model from Jumpstart. So basically just deploying the existing container for LlamaGuard to a SageMaker endpoint. Like I said, you could optionally fine-tune this as well for your own needs. But in this case, we're just deploying that LlamaGuard model. We're going to format the task template for LlamaGuard too. So when you're interacting with the LlamaGuard model, it does have a different expected input format, right? So we're formatting the task template specifically for LlamaGuard. So we're saying basically inside the output that it provides, it has to either say safe or unsafe. And then we want to see what category of unsafe that is. So these are the different categories LlamaGuard has, right? So like violence and hate, sexual content, criminal planning, all those different guards that you may want to put around your models before you go and deploy those. So in this case, it is criminal planning, right, that we're kind of hoping it detects on. So that being said, we have our LlamaGuard model deployed. We have our fine-tuned model deployed. This is just some function code to basically format the different inputs, right? Because you do have to have some wrappers inside to make sure you're formatting the inputs for these different models inside your inference or real-time workflow. So here we're going to go ahead and call the model again, now that we have LlamaGuard sitting in front of it. So what is the best way to plan a bank heist? So in this case, it does detect its unsafe content, specifically in the category of 3 that we saw before, which is criminal planning, and it blocks it. So it basically just gives our default message that we want back to the application. Similar, if we then try to ask a different question, this isn't criminal planning, we're just saying who pulled off the biggest bank heist. In this case, it does go ahead and answer it because it's not criminal planning. It is basically just asking a simple Q&A question. So I know I went through that quick. We have a short time frame, but just wanted to go through a few examples and some of the technologies that you can use to implement some of the recommendations and considerations that Amit talked about before. But now I'm going to turn it over to Diane from Rocket so she can tell you more about Rocket's journey through MLOps and FMOps.
Such an action-packed session for Monday morning. You guys awake yet? We're here to caffeinate your imagination. Let me share with you the story of how rocket companies turn all these innovation into solving one of the hardest problems, home ownership. Let me ask you this. What does home mean to you? What does home mean to me? Just like many others, it means a place of security, belonging, and dreams. Rocket's mission is simple. We want to make home ownership attainable to everyone. Since founding in 1985, we've originated 1.8 trillion in loan volume. We supported 10 millions of clients. How do we do that? Before that, share a little bit more about myself. I come to United States as a first-gen immigrant 12 years ago with nothing but a simple dream to make a better life. When I stood in my first very home to see the smile of my kids, to watch my family thrive, my dream came true. Rocket's mission is simple: help everyone home. How many of you are homeowner here? Raise your hand, please. See, like 90%. 92% of Americans aspire to own a home. Yet we found 40% of them believe home buying journey and ownership is the most stressful thing in modern life. 60% of Gen Z and millennial clients reported tearing experience of frustration during this experience. Our ambition is to transform that into a joyful experience. How do we turn this mission into reality? We do that by embracing an AI-fueled home ownership strategy. Our ambition is leveraging AI and data and deploy AI and GenAI solution in every corner of our business to truly transform the industry. At Rocket, we don't shy away from hard challenges. We do that by investing 5 years and $500 million, making our proprietary platform, loan origination system. We call it Rocket Logic. From there, we were able to provide end-to-end capabilities, starting from the client started looking for a house, to loan origination, to building the award-winning loan servicing experience. To help our clients improve personal finance, we were able to deploy our AI capabilities end-to-end in our powerful ecosystem, leveraging our proprietary technology. And from there, we grow ourselves into our iconic brand. Our journey of MLOps didn't start recently. We started our journey 10 years before GenAI became the sexy talk in everyday conversation. We now, fast forward today, we are able to scale up an infrastructure and support over 200 proprietary AI models in production. Just like Amit and Shelby mentioned, at the heart of this is an end-to-end robust data strategy and modernized infrastructure. We were able to partner with AWS and build this modern data strategy where all of our data is stored in cloud in S3, while we leverage Redshift for cloud warehousing, as well as capabilities such as lake formation to scale up at ease. This is the secret sauce of our modernized data architecture to make that happen. We appreciate the seamless integration between SageMaker and Bedrock so we can leverage and unleash our data science talent to build a combination of data science AI solution on top of leveraging and integrating with some of the newest GenAI technology. Let me tell you a story of how this evolution started. We started early days. We have 7 to 8 machine learning engineers build and establish out of our MLOps data platform. And that could not scale. We quickly realized that we did have our self-hosted MLflow. However, the deployment could take up to 8 weeks, and it wasn't acceptable. By fully adopting a modernized roadmap, we were able to enable now using the SageMaker with MLflow, which you guys saw in their demo earlier. And the results for us was huge. Now we no longer needing 7 to 8 engineers to manage our MLOps platform. Instead, we have one. Actually, it's Venkat. He's in the room here today with me. And he can also spend half of his time innovating because we are able to minimize the infrastructure overhead. The results speak for itself. We were able to successfully reduce our development time by 40 to 60%. We were able to scale up from owning a few dozens of models to now productionalize and operationalize over 200 AI and data science model in production. We were able to accomplish 3.7 billion of automated AI and data science-driven decisions for our business. By leveraging this stack, we were able to increase the velocity of our business overall, provide the personalized solutions our clients need. We improved efficiency while holding ourselves with high standard of accuracy. I want to show you guys a little quick demo of our chatbot. We've seen the QA chatbot. This is Rocket Assist, our proprietary chatbot leveraging the GenAI technology and the platform I was showing you. And we learned that 80% of our clients enjoy the chat experience. We were able to accomplish 3 times higher conversion than the traditional interaction. Overall, we are unlocking massive amount of efficiency for our business. We were able to process the majority of the 62 million documents we receive per year, and we can automate 65% of them, where 80% of the data points were automatically extracted with accuracy and precision, together saving 700,000 team member hours per year. Another demo is, as much as we care for our clients, we also care for our team members. Internally, we enabled what we call it Rocket Navigator. We always stay on top of the industry, making the newest GenAI LLMs accessible for our team members. And in the first month we launched this, we observed 18,000 interactions, boosting up team member productivity. From there, we were unleashing our business users' productivity as well. Since we start using these technology, integrate these solutions, our operational team members now can help 31% more clients within just a year. Our banking team see an increase of being able to support 15% more clients compared to the previous year. All of that because our deep belief is let the human do what we do best, which is building relationship, building meaningful connection as human to expand humanity, leveraging the power for AI and technology. Our dream didn't stop there. This journey just started. Let me pass it to Shelby to wrap up the key takeaway for today's session. Thank you.
Nice job. All right. We have more time than I thought we would have, so that's great news. We'll do a quick wrap up and then we'll actually leave 5 minutes for questions and answers. So some of the things you talked about today were applying human feedback, right, to create and evaluate high quality models with SageMaker Ground Truth. We talked about managing ML models and generative models in application experiments at scale with MLflow specifically. We also talked about using model evaluation with MLflow, but also the ability to use SageMaker Clarify as well with FMEval, as well as creating automated build workflows with SageMaker pipelines, and then also implementing the idea of safeguards, whether that's through Bedrock guardrails or through open source models that you put in front of your hosted models to then safeguard against unsafe content coming in or topics that you don't want to have your model dealing with. We also went through Rocket's story, so thank you so much to Rocket for coming and sharing their story and their journey. But before we wrap up, there are some resources here as well that you can dive a little bit deeper into these different resources across a lot of the things that we talked about today. I'll give a second for taking pictures of those resources. But within there, we do have just kind of the general SageMaker MLOps page where we kind of publish the latest and greatest in features and that sort of thing. Some code examples, as well as a generative AI workshop that our team works on and continues to iterate on with a lot of different examples for things like fine-tuning, pipelines, experimentation, all those different things. And then last but not least, just our LinkedIn profiles. Happy to connect. I know I love to connect with others in this space. I know Amit, Diane do as well. So feel free to reach out with any questions that you have or anything that you want to talk about. Happy to always interact with others.